Watching. Today I'm working more on my quantitative model in Python to make money off of the stock market. So let me talk about real quick where I'm at, what I've done so far, and what my plans are going forward, and what my plans are for today specifically. So let me pull up the PowerPoint. So this is the PowerPoint I'm tracking all my progress in. So here is the outline for the model. So I have data for stocks. I want to trim this data down. I don't want to use every stock that I have in the database. I want to trim it down to a useful universe. So you don't want to use things that don't have a lot of volume. You don't want to use things that have idiosyncratic movement, basically, to train your model. You don't want to train your model on idiosyncratic movement. You want to train it on good movement. So I have the stock universe. Once I isolate the stock universe, I want to feed this into a model and train the model. And once I have a model working, I want to feed this into a portfolio model, which allocates the money that I have according to what the model's predicting. So here's where I got on the first version. This basically took all of January. I started out using NASDAQ data. It turns out that wasn't efficient. That wasn't going to be useful. I switched over. I found a better database. The link for that is in the description. Let me change these to white. I don't know why they weren't already. Yeah, so I switched over to a better model or a better data source. I then did some basic analyses of that data source. So this is like looking at fundamental features. This is looking at how stock performs with relative to the other stocks in the sector. So in this case, pharmaceuticals. Then I incorporated that all into a light gradient boosting method model. I got 51.5% directional accuracy on the model when I was predicting returns for a single day. I thought this was pretty good. So then I incorporated this into a portfolio model, and I found if I'm picking the lowest N number of volatility stocks per day, the lower N is, the better the model performs. So here is 500 stocks per day. I was underperforming the S&P. 100 stocks per day, I was basically matching the S&P. 20 stocks per day, I was beating the S&P. And 1 stock per day, I was beating the S&P by a significant margin. So I looked through, if I change N here, how does the Sharpe ratio perform? And you want a Sharpe ratio above 1 is generally considered usable. And so you see the only strategy that had a usable Sharpe ratio was if I'm picking 1 stock per day. That's pretty fragile. So I tried increasing the threshold. I found that if I increase it to 0.51, that's not really helping at all. If I increase it to 0.52, that's a slight improvement, but not really helping at all. But then when I increased the threshold to 0.53, that helped a lot. I got much higher Sharpe ratio. In 0.54, I got a really high Sharpe ratio, but 0.55, it wasn't making any picks. And so since I, if I look at this, let's do this strategy with the really high Sharpe ratio, it's just fragile because if I increase it just a little bit more, it's not going to make any picks. Nothing's going to have a higher threshold. And also it's picking 1 stock per day. So it's kind of really fragile on 2 metrics. And that's not good. I want something that's going to be really robust. And so my initial goal was to get improve this from 51.5% to 53 or 54%. It turns out that's actually not the metric I want to be looking at, but this is where I was at the end of January. So I wanted to go through and do a kind of rapid analysis, rapidly iterate on the model, try all sorts of different features, and determine what works really well. So before I could do that, I had to clean up the code base. It was basically a big, huge, giant mess. This is what I did during February. And I went from, originally I was making a new script every time I defined the universe differently, every time I changed how the model worked, or every time I wanted to do a new portfolio strategy. And so that made dozens of files, and it was going to quickly blow up into hundreds of files, and that wasn't going to be usable for me. I forgot to mention I have a second goal in this analysis, which is that I want to make something that's usable for me, but not only that, I want to make something that's usable for other people. So I'm uploading all of this into a GitHub repository. Let me pull that up really quick. The link is in the description. If you go here, you see here's the GitHub repository. It really helps me out if you download this and try it. I would like some feedback on what you think about it. Basically, all of the analysis that I'll be doing today and everything that I've done moving forward once I cleaned up the code base is going to be using this. So I'm using this database, and every time I update and add some new stuff, I'm updating this database. So it would help me if you download it. It would also help me if you star it, if you watch it, and if you follow me on GitHub. Those really help me a lot because it helps raise my coding profile, helps me get freelance coding gigs and jobs. So this took a really long time. So like I said, this is where I was at the end of January. I started this project really at the end of last year on like December 29th. But it's basically the project for this year. So by the end of January, I had this and I wanted to rapidly iterate. This actually took all of February, cleaning up the code base. And one of the thing that really took so long is before I explored everything, I don't want to just be going and adding features willy-nilly and have to be constantly editing the code. So I went through and added every feature that I could possibly want and every target that I could possibly want. And from there, I'm able to really easily iterate on the model. And so once I had all features and targets, it was time to iterate. The first step was just adding all features to the model. You can see this didn't perform that well. But like I said, it turns out that the directional accuracy actually isn't the metric that I want. I want some more advanced metrics. So I started looking at the metrics here. So I still have directional accuracy and root mean squared error, but I actually am not paying any attention to those anymore. I'm looking at the mean daily rank information coefficient. I'm looking at the standard deviation of the information coefficient. I'm looking at the ratio of the information coefficient to information. That's these two values here, so daily and annualized. And then I'm looking at the t-statistic. One thing I found before I added these was that the model performs better the longer I'm looking out into the future. So this was my first really good result that I was able to use to improve the model. And the reason for this is if you're predicting daily returns, a lot of the movement that happens in the stock market is in after hours or in pre-market trading when the big institutions are able to move things. And so if I'm buying every day at the market open and then selling every day at the market close, it doesn't capture any of that movement that's happening between the close and the subsequent open. I'm missing out on all of that movement, so that makes doing one-day predictions really hard. But if I look further out into the future, if you're using say 5-day return predictions, well, 4 out of those 5 days you're getting that change, and so that's what makes this model useful. Okay, so then I incorporated the cross-sectional z-score and used that on the target and all features, and that actually improved things a lot. So if you look at the values here, I'm getting basically everything that I want. The IC is good. I want an IC above 0.01, so this is 0.02, so it's really good. The standard deviation is higher than the information coefficient, but this is pretty standard. Initially, I was concerned about this because Claude told me that the standard deviation of the information coefficient should be orders of magnitude smaller than the mean information coefficient. I found this paper which showed it looked at all sorts of historical studies, and it showed the information coefficient and the standard deviation of the information coefficient. And the standard deviation was always higher, and it was higher at least 3 times as high, and it went all the way up to, I think it was 12 times as high. So I'm not really concerned if the standard deviation is high, but I want it to be as low as possible. Then I did I looked at a correlation matrix of all the features, and then I found another paper, oh no, this is actually from a book. but this implements a good method at trimming the features. So basically things that are really highly correlated are going to be redundant. And so instead of, the model kind of gets confused because it's looking at the same things in multiple features. And so you want to remove the redundant features, but the question is, if these two features are highly correlated, how do you pick which one to remove? Well, the way to do that is you look at the correlation to all features and then get the average correlation for each of those. And whichever one has the lowest average correlation, that's the one you keep. The one with the higher average correlation you want to get rid of. And so then I looked through and see, okay, if I'm trimming the features, do I improve model performance? And actually here I found that I'm not improving the performance. I also wanted to see if I forbid it from dropping. So the light gradient boosting method, when it's doing the training phase, when you're training not the training phase, when you're tuning the hyperparameters, it drops out some of the features. And so, and it does that randomly. So, and that kind of makes the LGBM more robust. But if I'm already doing this, I don't want to drop the features. So then I wanted to see, okay, if I don't allow it to drop features, how does it do? And it actually performed worse on every metric. So, and then the last thing I looked at yesterday was if I increase the threshold, so it's dropping features that have over 75% correlation. And so I wanted to see if I increase that threshold up to 90% correlation, can I improve the model? And I wasn't improving the model. And so basically the question is today, do I want to do this, removal of features? This is kind of a best practice, is you don't want to feed infinite features into your model. You don't want features that are correlated, but when I remove correlated features, it's actually performing worse. And this is a really good result that I got here. I don't think this is ready to be incorporated yet, but it's really close. So once I get a model that works, I'm going to do paper trading. And the other thing is that I have all these things, these to-dos, which will improve my model. So I want to add fundamental features. I want, so what am I going to do today? I could add on fundamental features, but all these to-dos are things that I want to do, but first I really want to get to the bottom of this correlation analysis. So let me pull up Google AI Studio, and I'm just going to talk to it to kind of try to sort through this problem that I'm having. Okay, what else did I do? Initially, I was removing one from pairs with 75% correlation. I attempted to improve performance by increasing this threshold, the correlation threshold, to 90%. This also gave worse performance. What is the cause of this, and how can I improve the performance of my model? Would actually made my model worse on every metric. And the metrics are information coefficient, standard deviation of the information coefficient, the ratio of information coefficient to information, and finally the t-score. And how can I improve performance? All right, let's see what it says. I got sunshine on a cloudy day when it's cold outside. The metrics you're using strongly suggest you are working on a quantitative finance or algorithmic trading model. Isn't that what I said? No, I guess I didn't say that. In this domain, signal to noise are notoriously low, and behavior can be highly counterintuitive compared to textbook science data practices. It is incredibly common for the removal of highly correlated features to degrade the performance. Here's a breakdown of why this happens, followed by better strategies. Why did removing correlated features degrade performance? The residual is the actual signal. If feature A and feature B are 90% correlated, they share 90% of their variance. However, the remaining 10% might contain the exact orthogonal alpha your model is capturing. LightGBM can implicitly calculate nonlinear spreads by splitting on feature A and then splitting on feature B further down the tree to isolate that 10% difference. By removing one of the features, you destroyed the model's ability to find that spread. LightGBM usually relies on column subsampling. If you have a feature fraction of 0.8, the model randomly hides 20% of the features. Okay, so I already tried that. Flawed removal heuristic. You mentioned dropping the feature with your highest average correlation to other features. This is a dangerous heuristic. You might have inadvertently removed the cleanest proxy of your signal. A feature with high correlation to other features might be capturing a strong underlying market factor. Dropping it based strictly on peer-to-peer correlation completely ignores its predictive power relative to the target. So that makes it seem like I don't want to drop features, but things I've read make it seem like I do want to drop features. You don't want too many features. In finance, features are incredibly noisy. Two 90% correlated features are essentially two slightly different noisy measurements of the same underlying truth. Giving the model both allows it to implicitly average out the noise. Removing one. Okay, how to actually improve performance. If you want to reduce dimensionality, remove noise, or improve your ICIR, try the following techniques instead of blind correlation-based dropping. Target-aware feature selection. If you must drop one feature from a highly correlated pair, never do it based on pure correlation. Instead, evaluate them against the target. Look at the feature importance. Feature bit A and feature B. Let the model handle it. Tree models are theoretically immune to multicollinearity. Instead of manually dropping features, force the model to penalize complexity. Tune LightGBM's built-in regularization hyperparameters. L1 will cause the model to mathematically ignore useless features and naturally push the split weights of redundant features to 0. L2 smooths out weights between highly correlated features, preventing the model from over-relying on one noisy proxy. Min gain to split increases the threshold required to make a split, preventing the model from making useless splits on pure noise. Okay. Permute your target variable. Train the model 50 times and record the feature importances. Compare permute. Doesn't that mean change around? So am I going to do 50 different targets? I guess you'd say, what can make me feel that way, my girl? Okay. So how do I want to do the dimensionality reduction? So let me show real quick. So I've tried one method of dimensionality reduction. So I think actually I'm going to have to go in and explore this and figure out what is the best method of dimensionality reduction. Where'd the PowerPoint go? Okay, we have 5 viewers, so I'm going to take this opportunity to say please subscribe. Please check out the GitHub for this project. The goal is to make something that's usable, not just for me, but for you as well. So it would help me if you download it and try it out. Give me some feedback. It would help me if you star the repository. It would also help me if you watch the repository and follow me on GitHub. Also, join the Discord. And, okay, so what's the best method of dimensionality reduction? Reduction. And do any of these improve performance? So the first method was removing correlated features with, what's the approach? Kuhn and Johnson approach. This worsened model performance. So the next thing we could do is a PCA analysis. So principal component analysis. Are you going to bed? Yeah. Okay.
Ooh. Streaming?
Yep. And you're gonna be dreaming soon. Sweet dreams.
Love you. Happy birthday.
Love you too. Thanks, Mom.
Happy Pi Day.
Thanks for a good birthday. Oh yeah, happy Pi Day too. I totally forgot about that. Although some people like Tau Day better.
Oh, really?
Tau is pi times 2, 628.
Oh my god. Alright, see you in the morning.
See you then. Good night, Dad. Okay. Calculate correlation matrix. Okay, so let's give it the model class. Everybody's watching her, but she's looking at you. All right, let me pull up Python. Oh, Buddy wants in. Come on, Buddy. Come on, man. Good boy. Do I have a GPU? Oh. So what is this? Reg alpha and reg lambda. But here I'm saying Hmm. So it seems like I'm already using both. Okay, so this one's gonna take quite a while. So, um, what is model 13 again? Oh, 12, same as model 11. All right, so let's go back to model 12. And maybe I should just start with highly correlated features. Well, let me put a comment in the chat saying to subscribe because I think that helps me out. Okay, so I'm going to start with highly correlated features. So let's just put this in here. All right, so things that are highly correlated. First, log close, log high, log low are all highly correlated with each other. Let's take out the border. Okay, log volume is, so what is that? That's like 50% correlation. It's fine, I'll leave it. I want things that are 0 though. Or 0 correlation really shows that it's a nice unique feature. So log returns correlated with gap size, right? Gap size. So log returns this column, yeah. Log return and gap size are highly correlated. This thing's correlated to some features. RSI 20 day. So RSI market SPY return, it says, isn't correlated to anything. Okay, so we just want things where it's starting to get dark red, which is this. So this guy. Hey, JRX. How are you? What's going on in your world? Oh, look here. So moving average crossover is highly correlated to volatility z-score. This has some high correlations, but nothing crazy. This guy has some high correlations. Trend slope. That's getting high, but nothing crazy. Here's some high correlations. So these MACD, oh, of course, the two MACD features are correlated. So I have to think, because do I really want to add both MACD features? Oh, the guy below MACD, so angle is highly correlated to something. Oh no. That's itself. Okay, never mind. These two are highly correlated to things, and I might just add the one beneath it. So what, these guys? Oh. But angle isn't highly correlated with anything, but these guys are. 2. What about this down here? I may as well add it. Oh, dang, I finished my Red Bull. That guy doesn't have any high correlations. This has a high correlation. B bands. And this guy, so these two. So the middle and lower B bands have some correlations. And nothing else really other than, oh, these two guys are highly correlated and this guy, so. This guy and the two above it. Well, of course, the stochasticity is correlated to itself. What the hell? Why does that look so bad? Okay, I'll just I'll put this in, but then just write in the highly correlated features. Wait a second. So when I'm doing the correlation matrix, I didn't get that on. Yeah, I'm not doing it on every feature. Model 12. Yeah, that's what we want. Hey, Patty, nice name you got there. We have the same name. Unless your name is Patty. I'm assuming it's a nickname for Patrick. Anyway, nice name. Regardless. Ho 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 ho. Um. So if I have all these, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, I guess I could just put them all in here and then draw conclusions later. So, oh hey, what you using to backtest and what kind of data? So the data is the data I'm using in the description. It's open, high, low, close volume data. Um, wait, what? Oh, the description. Um, and the I just am splitting the data. Um, right now I'm not looking too much into back testing. I want to find everything that's going to improve the model first. So now I'm trying to basically get a method to remove correlated features. I tried removing correlated features with this method, which is from a textbook. Um, but when I'm doing that, I find that it actually makes the model worse. Uh, um, oh yeah, this is so if I'm trimming the features, it's getting worse on every metric than it was before. Then I looked in, what if I stop the light GBM from dropping features after I trim them, and that makes it worse. And then I say, okay, what if I increase the trimming threshold from 0.75 to zero point 0.9, and that makes it worse. 0.9 is worse than 0.75, which is already worse than all features. So I'm trying to, now I'm going through feature by feature, so I identified the highly correlated features and I want to walk through them one by one and remove them from the model and see if I remove only one of any of these features, am I increasing the performance of the model? And I hope the answer will be yes. Oh, well, I'm happy you asked because you're. This is my next to do. So, this though, I need to write a bunch of code for it. And so I'm gonna hold off on doing that until I at least start this because this is really easy to do. Just remove a feature from the model. Um, and so I'm gonna at least do one of these. Hopefully, I'll walk through a few while I'm making sure the code works well for this. And then I'll test this once I finish writing the code for that. Shouldn't take too long, but this will kind of maximize the efficiency of my time. So first, let's remove log close. So I'm going to highlight all of these yellow, and then once I do them, I'll change it to green. So log close. If we remove that, Oh, so log close actually isn't in there. So why is log close getting added as a feature? It must be happening inside of here. Log close, log high, log low. I guess I can say I could actually just incorporate it down here. So I'm adding the features to the data set. And the name of it is log underscore close. So wait a second. Why is that? It should, the feature should be everything that includes an F. Well, okay, either way. Let's just try, so we get the data, feed it into the model, add features, add target. And this is just passing features and target into the model. This, when I split the data, it's actually getting them. So then we'll say model dot data dot drop something access equals 1, in place equals true. Oh, it's because it's removing the non-feature keys. Okay, so let me put this back in here. Because it is training, so that kind of answers up the question I just had. It is training only on features. So I don't need to worry about any of that crap. I do need to worry about this. So the first 5 down to gap size, I don't need to worry about. That'll make this easier. Okay, so let's try to remove the moving average crossover. So let's change this to just go straight down. And then this will make removing the features a lot easier. Okay, so first thing I'm going to remove is moving average crossover. And I want to run model 12. Okay, so I'm gonna let that run. Now I want it to incorporate the PCA analysis, so it's saying give me some code to do that. I just want the new thing. That's not gonna run because I made it 12, damn it. Wait, what did I do? Oh. So why is that grayed out like that? Oh. I need to bring this back. Good. Oh wait, just a sec. Oh yeah, this is model 12. Okay, now it's going through it. Let me see. Can I speed this up by getting rid of anything? So Safari networking. Is that YouTube? Next server. I don't even know what the hell that is. Zoom, we could definitely get rid of. Opera, we don't need open. WebEx, we don't need open. Probably just terminate the method. Oh. WebEx. Quit. Okay. Let me delete out of exit out of unnecessary tabs. Hey, I got 2 new stars on the repository. Thanks. That really helps me out. And another follower, so thank you very much. I appreciate it. And someone's watching it. Wow. Thank you, thank you, thank you. Alright, where are we at? Trial 42, so it's getting close to trial 50. Come on, hurry up. 45. So is this ready to run? Yes. So I'm gonna switch this back to run model 13. Oh yeah. Oops. Whoa, was it already doing model 13? I wonder if this was model 13. So we shouldn't see moving average crossover. Regime, MACD, log ATR, B-bands, spread, normalized ATR, Hurst skew, ADX, regime, SMA, volatility, regime, VWAP, trend slope, B-bands, autocorrelation, return on ROC. I forgot what that is. ROC. Well, anyway. Momentum. Where was I? Damn, I lost track. All right, momentum, B-bands, trend slope, spread, B-bands, normalized ATR, angle, VWAP, MACD, EMA, log ATR, spread AR, B-bands, kurtosis, MACD, autocorrelation, B-bands, RSI, Hurst skew, ROC, EMA, volatility, angle, Hurst, volatility, ADX, norm ATR, RSI, autocorrelation, B-bands, spread, VWAP, kurtosis, normalized ATR, skew, SMA, EMA, volatility, B-bands, autocorrelation, B-bands, ROC, SMA, ADX, Hurst, EMA, Z-score, volatility, C-score, trend slope, volatility ratio, gap sigma, skew, SMA, RSI, Z-score, angle, B-band, Z-score, kurtosis, ROC, volatility ratio, gap sigma, Z-score, VWAP, Z-score, angle, trend slope, Z-score, RSI, ADX. Good. So this is the model that I was concerned with. Whoa, if I do the quantile spread on this does look like the staircase I want. So, or sorry, not quantile, decile. So it should be that every 10% the performance is improving. And that's what we see. So this is a good result. Okay, and then what's the performance? Okay, I'm actually going to look at this. Okay, now we're going to run model 13, and I've changed it to do PCA. Okay, so let's look at it. Let's actually just make a table. So we're going to say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 metrics we want to go through and get rid of. So 12, we should get 12 rows. And then we want a metric for each. So IC standard deviation, ICIR daily, ICIR yearly, and then T statistic. So this is 8, so really 7. We want what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Plus 1, so 12. We have 7, so 1, 2, 3, 4, 5. And we'll say feature removed. We want the IC. We want IC standard deviation. We want, I always forget what's the shorthand symbol for standard deviation. Oh, I should cancel out all that crap. Get rid of that. Get rid of that. Okay, so this is really slowing everything down. Get rid of this. Get rid of that. I thought it was sigma. Okay. All right, so if I'm not removing any features, what do I get? IC is 0.0229. IC sigma is 0.1027. ICIR daily, I guess it's not daily, it's just ICIR. 0.2232. ICIR annual, 1.5843. Robust ICT statistic, 2.3191. Oh, let's add a column. T statistic. Okay, then mean daily target spread. Spread win rate, estimated annual Sharp. I guess, yeah, I don't need that. So now we want this to fit, so let's just get the whole thing. That should still be big. IC can be way smaller. Oh, let's just make, okay, so make that bigger. Make this way smaller. Make this way smaller. And T statistic here is 2.3191. I'm out of Red Bull. Alright, I'm gonna go get a drink real quick. Maybe a seltzer, maybe a beer. Let's see. Alright, so moving average crossover. Real quick, let me see, did this finish? Oh. Oh, really? Line 930. Oh. Oops. Okay. So let's go back to getting this. So mean rank IC goes down to 0.0206. So IC sigma is 0.1182. Robust ICIR is 0.1742. Annualized ICIR 1.2365. T statistic 1.8101. So worse, 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 worse. So worse on every metric. Oh, so now it's going through and performing the PCA reduction. So am I using, oh, I wonder if I could run two models at once. I kind of think no. Oh, this was network. So CPU, we're good. Memory, we're not great, but I'm gonna try to run both in parallel. So this is PCA reduction. Let's get rid of that. Right. Do model 12. Tested on model 12, yeah. Okay, so let's put moving average crossover back in, and now let's take out VWAP z-score. Okay, now let's see how this changes things on the activity monitor. Whoa, the CPU load. Okay. So the CPU load does max once I'm tuning the parameters. Okay, I'm gonna need some high performance computing crap. But if I ever get to the point where I'm making money from the model, making money from my YouTube, or making money from selling my picks, I'm gonna get a better computer. That's gonna be the first thing. So what I can do right now is look at incorporating the fundamental data. So let's get rid of data retrieval. Which setup data do I say to call? And thank you, Prithville Ready, for starting my repository and following me. That really helps me out a lot. Yeah, this really, the more people watching, the more people start, and the more people that have forked the repository, the better it looks. Oh, data retrieval 2 just gets rid of ETFs. Okay, so here's the performance with that reduction. Now, at first look, this might not be better, but you know, if these are basically break-even regions. I don't know. Here are the metrics. Oh, I shouldn't have exited out of that. I should have saved it. Whatever. Okay, so does this improve? 0.0229. Oh. What? Oh, okay, so switch them. I didn't change the model, did I? Okay, I'll look at that in a sec. Now I want to try removing VWAP Z-score. This is ready, right? Model 13, model 12. Oh yeah, model 12 is what I want. Hey Ash, I'm good, thank you. How are you doing? Today was my birthday, so I have a twin brother. We spent it together. We went to the beach and had a party at the beach. It was a lot of fun. I don't know if you could see that my face is a little bit more red than it usually is, but I got sunburnt. But I'm having a good day. It was an excellent day. How's your day going? Okay, so IC is worse. Standard deviation is worse. ICIR worse. Both of them. T statistic worse. Okay. So there's 5 viewers right now. Please, let me take this opportunity to say, please subscribe. Please go to the GitHub, download this, try to use it, give me feedback, star the repository, watch the repository. If you forked the repository, that would help me out. And follow me on GitHub and join the Discord. All of the link for everything is in the description. But all that stuff would really help me out. And joining the Discord would just be fun because I want to get people started talking about things, but it's kind of hard to get off the ground with that. So if you got any ideas about literally anything that's interesting, join the Discord and comment it. We want to talk about it. There's like maybe 10 people in there right now. Okay, so neither of these work. I've removed the Z-score. I'm running that now. What else do I need to do? Oh yeah, so back to incorporating fundamental data. So all data with fundamentals dot feather. So I put it in data / all data with fundamentals. Hey, thank you. I didn't have any birthday wishes, but I wish this model works. I wish I could get a really good repository and I could get a great model which works well. Okay, so I don't have it. Let's see how that performs. Good, this finished. So there's the feature importance of everything. So this is also worse. Next, let's delete the volatility z-score. Alright, now let's try removing trend slope. Oh, I'm on volatility z-score. Or... oh no, damn it. What did I remove now? What? Oh. Okay, so this is with volatility z-score removed. That looks nice. I'll just put a note. Okay, so next is trend slope. Okay, information coefficient. Zero 0.0212. Still worse. Sigma 0.1151. Worse. ICIR daily 1.838. Worse. .3052. 1.9106. Trial 13, okay. We're marching through it. We're incorporating. So I'm going through this analysis. This is going to take a while because I need to run the model. What, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I need to run it 11 times, so that's just going to take some time. I tried that. That didn't work. I'm looking for other ways to trim the features now. And what else am I doing? Okay. So this is the one I'm marching through. We're going to see how this performs. So far, the first 3 that I removed don't improve the model at all. And then also I'm incorporating fundamental data into the model. Damn it. So it's saving it into data. So this actually should be / data. Unreal. Alright, so it's getting that data again. Basically, I don't want to pull the data from DoltHub. Every time I want to do an analysis, I want to pull it all into one file, and that will allow me to rapidly do the analyses that I'm doing. Okay, so it's getting that. What's this guy at? It's almost done pruning. So then it'll run the model, spit out the results. Let's get this one ready. So let's remove MACD. Okay, here's the model results without the trend slope. And am I improving the performance at all? It actually looks pretty close here. So this got up to 50. The base model went up to... what'd the base model go up to? Oh, a fair bit above 50, so I bet this is going to be worse. But let's see. Model 12. So a slope removed. Now, next thing I want to remove is MACD. What? Seriously, I'm not adding MACD. Oh, feature engine. MACD. What the hell? How did I not add MACD? Okay. So does adding MACD improve model 12? So when performing correlation analysis, when performing feature trimming by, what do I call it here, single feature removal. Oh, that's because it doesn't use a time period. So when was the last time I was incorporating MACD? What? So never mind, I do have it. Okay, so IC. Worse. But not that much worse. Standard deviation, worse. Okay, there's 6 viewers, so I'll take this chance to say please subscribe. Please go to the GitHub. Download the repository, star the repository, watch the repository, follow me on GitHub, and please download or join the Discord, and let's talk about interesting stuff. And thanks for watching, of course. Okay, so we should have it. All data with fundamentals, WITH. So on top of what we previously had, we now have ROIC, operating margin, and days since release. Okay, so this just finished running. Model without the MACD. Staircase looks alright. So this seems like it's not going to be too bad. But I think it'll still be worse. Yeah, it is. So 0.0209. Okay, so we removed MACD. Now let's do SMA next. Okay, so MACD, the IC is 0.0209. IC sigma is 0.1107. ICIR is 0.1891. Annual 0 or 1.3426. T-stat is 1.9653. And then simple moving average. Oh, I haven't done that yet. So MACD is done. You take training data and create a duplicate shadow column for every feature. The shadow column contains the exact same data but randomly shuffled. You train LightGBM on this combined data set. You find the highest feature importance score among all the fake shadow features. Any real feature that scores lower than the best fake feature is pure noise. Okay, but can't you just make one fake feature? Whatever. I'll try that. Okay, shap pruning. So specifically, I'm looking at model 12. Okay, so there's shap pruning, Baruta, style, shadow feature, method. Null importance. I'm already doing that, so. Oh, man, I'm tired. Okay, we're already doing that. So now I have to think about how to incorporate fundamental features, but let's try adding this first. get rid of that. So the model's finished running. Once again, a nice staircase. But too bad because it's not going to work. But here I can say volatility C-score, SMA, we also got a nice staircase. Here's the performance. And here we want to add shadow feature selection. And I'm like, hell no. Been waiting too long, I've been waiting. Hell no. I want that cruel love, come here, baby. Alright, so here's SMA. Rank IC is worse, but not far. Hey, Sir Night Night. How are you? Here I am working more on the model every day. Gotta get down to business, right? ICIR. 0. Right now I'm working on trimming the features. So, yesterday I tried kind of this simple method for trimming the features. So you're looking for pairs of highly correlated features above 75% correlation, and then dropping the one that's more correlated to the rest of the data set. So I did that. Oh, and this is what happened. It performed worse. Then I tried, okay, do that, but don't let it drop any features. It performed worse. Wait, what do you mean? Oh, yee. I interpreted it. I didn't even realize that said yee. I interpreted it as yerp. Yee. Yeah, so I did that. And then I increased the threshold from 75% to 90%. That did worse. I tried PCA reduction, principal component analysis. That did worse. Now I'm going through all of the highly correlated features and trying to see if I remove them one by one, does removing one of those improve the model performance? ICIR annual 1.3855. T-stat 2.0282. Okay, so SMA is done. Now I'm trying this other method for removing features. So correlate the features to the target, make fake features, jumble all of the data, and then remove any features that are that perform worse on the target than the jumbled data. No, how do you check for overfit bias? No, so I'm gonna add that to my to-dos. And I just added the fundamental data. Oh, well, I added the data set, but let me say, yeah. I need to figure out which fundamental features do I want in my model. Uh, uh. Okay, so the new feature. Um, oh, because I fucked up the indent. You can see split your data between test, train, and test. Oh, to check the AUC, I was printing that out, but I wasn't sure what AUC is. Area under curve of the ROC curve. Measures the machine learning classifications model performance by calculating its ability to distinguish between classes. Yeah, well, I already split it into train and test, and then I'm calculating the metrics on the test. Oh, check it on each iteration of the model. I've split the model, but what? Oh, I haven't added. I'm printing out all of this stuff, but I'm not printing out things that show uh like the accurate. I think when I looked, it says if your train data set is really accurate and then test data set is inaccurate, then you're in getting overfitting. But and so I do have it split. I just when I'm going through in here, I'm not getting the test data set at all. So I have to think about how to do that. I guess I can just give the information coefficient. Um, yeah, I don't know. But that'll be. I put that on my to-dos, so that'll be like one of the things I work on before I feel happy about this model. So these are all the things I have left to do. Before I can, go ahead with this model. Because the other night, um, when I got this, I was like, oh, that's pretty good. And everything looks good. It's hitting every metric I want. It's getting above the threshold that I'm looking for. The staircase thing looks good. Um, so I think that's really good, but I need to go through and kind of ruthlessly analyze it and try to improve it. Okay. Thanks. Yeah, you said that the other night. That's what made me confident because it was hitting everything that I wanted. But then when you said that, that looks really good. I thought, yes, validation. Um, so I like this. I want to move forward with it. But before I move forward, I want to, do everything I can to improve it. And really, if I do everything I can to improve it and I find some improvements, then great. I like it even better. If I do everything I can to improve it and I don't find improvements, then I'll feel pretty confident in it. So this is so far the best uh, feature selection that I've used. Let's see what the performance is, though. Zero 0.0225, so that's worse, I believe. Standard deviation's worse. Okay, I'll go through and check that stuff. Since I'm walking through the features that I'm dropping, turn this off and turn this guy on. And then model 12. We were dropping SMA. Now let's drop EMA. And just to check, is it running? Yeah. I really think the main thing, all this is like kind of just fine tuning. What's interesting about your prediction performance is that it's Gaussian. Prediction performance it's Gaussian. How do I? Oh, you mean that it's evenly distributed? Yeah, if I plotted these, it would be Gaussian. But why is that interesting? Isn't that kind of standard of a good model? Your performance should be Gaussian. Or maybe you mean it should be like a nice distribution, but maybe you think it should be a different distribution. And I always forget what monotonic means. I think that means linear. Oh yeah, that does mean. Come on, Pat, be confident in yourself. Yeah, it's linear. Well, yeah, since it's linear, it looks Gaussian. If it was like exponential, then it wouldn't be Gaussian. So, but I'm not sure if you're saying like that's what makes the model interesting, but or if you're saying, oh, that I'm not sure if you're saying I'm not sure what I'm saying. I'm pretty tired. This didn't improve the model. Okay, so 0.0225, just barely slightly worse. Standard deviation is worse. ICIR is worse. Annualized is worse. T statistic is worse. So, worse on every metric. Though, IC is just slightly worse. Okay, this is almost done. Whoa. That looks like it might be performing better. Oh man, it's just barely worse in the IC statistic. Hey Omar, Thanks. Option market. What advice? I don't know. Really, the best advice is work every day on it and use chat models to like assess yourself and improve yourself. Lots of people say use what's it called when you're using the AI inside of the command line or inside of your coding software. You have to pay for that usually, but people keep telling me to use that, and I'm pretty confident that that would make me much more efficient. I just don't want to pay for it right now. Um, but that is something to do. Yeah, and then really just talk to chat models and say, how can I improve this? Here's my strategy. Does this make sense? What's the best practices? And it'll kind of go through and synthesize all sorts of things. But anyway, subscribe if you're interested because I work on this every day. So I'm just plugging along on this. So you should subscribe if you're interested. Join the Discord. There's people in there who are working on the same thing. So they'll have good advice for you. The links for this stuff's in the description. And then also, it really just helps me out if you go to the GitHub, which is also in the description. Download it, star it, fork it, watch it, and follow me on GitHub. All that stuff really helps me a lot. Um, okay, so now we've finished that guy. And that's going to be it for tonight because I am just really tired. I'm going to go through the rest of this tomorrow. It doesn't seem so far. I've removed 1, 2, 3, 4, 5, 6, 7 features. Doesn't seem like any of them are improving performance. I've tried 3 different methods of automatically trimming features. None of those 3 are improving performance. So I'm going to keep going through this feature reduction analysis and try to see is anything going to really help out my model performance. I also incorporated fundamental data into my data set today. So I want to incorporate every fundamental feature that I might want. Um, and so I'm hoping that will also improve performance. I don't know what the best model is to use. Honestly, I've only been using light gradient boosting method models. Um, and that's what I've been doing this whole time. I'm not to the stage where I'm trying to test out some different models yet. I'm really stuck in the weeds on improving this model. It seems pretty promising. Uh, like we were just discussing, here are the results for Model 12. And so now I'm going through seeing can I trim the features to the model and improve the performance in any way. But if I can't, I'm going to be happy with this model. I'm going to make a new model where I'm adding the fundamental data, and I'm going to see, how's that work, kind of do and if it is better, then kind of do the same thing I'm doing now, try to ruthlessly trim it. Um, and But this is pretty promising. So by the end of March, I'm hoping to have a model that I'm testing on paper trading. So again, I said I would have that by the end of February. So I got delayed a little bit, but I'm making really good progress. So anyway, thanks for watching. Have a good rest of your night. Adios. Can't. I'm gonna be now try to and but this is